Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam and other exams related to physical science. Okay, so this is the lecture number 26 of quantum mechanics, in which I'm going to discuss Born approximation. Okay, and also I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. Okay, so this is the lecture number 26, Born approximation. I'm going to start now. Okay, so Born approximation, guys. Okay, Born approximation. Born approximation. Okay. Meanwhile, just let me check whether I'm audible or not. And also, yes, I'm audible. So I will proceed further. So Born approximation. Born approximation. Born approximation scattering. Born approximation scattering amplitude. Scattering amplitude is okay. So Born approximation scattering amplitude, which is f, which is function of theta and phi, is equal to minus 1 upon 4 pi integration ur, this is the potential, guys. Okay, e to the power minus iota q dot r d tau. Okay, q dot r d tau. So this is the scattering amplitude. Okay, Born approximation scattering amplitude. And here, since u, that is the potential, which is function of r, is equal to 2m upon h cut, 2m upon h cut vr. Okay, 2m upon h cut vr. So we'll put this value here. So this going to be that scattering amplitude is going to be, which is function f, which is function of theta and phi, and this is going to be equal to, if you put this value, so this will give this value minus m upon 2 pi h cut square. Okay, 2 will cancel 4 by 2 times. Okay, so minus m upon 2 pi h cut square integration vr, which is function of r, e to the power minus iota q dot r d tau. Okay, this is very important formula, guys. We'll solve question. Okay, so you need to note down this formula and memorize it, guys. Okay, very important formula. So f theta phi is, that scattering amplitude is, minus m upon 2 pi h cut square integration v, which is function of r, e to the power minus iota q dot r d tau. Okay, next here, this is the wave vector k. Okay, this is the wave vector k, and this is the wave vector scattering, right? After scattering, this is the wave vector uh, k dash. Okay, this is k and this is k dash, guys. This is the instant wave vector, and this is the wave vector of wave after scattering. Okay, so this is k dash vector. Okay, so from here we can write k dash vector plus q equal to k. Okay, so from here q is this. Okay, then from here value of q vector is going to be k minus k dash. Okay, so here we'll take mod square on both sides. So this is going to be mod square of q equal to, this is vector mod square of k plus mod square of k dash minus 2 mod k mod k dash cos theta. Okay, cos theta. And for elastic scattering, if this scattering is elastic, okay, for elastic scattering, this k mod of k equal to k dash, then there wouldn't be any k dash, there wouldn't be any change in wave vector, right, if there is if it's a elastic scattering. So in that case, mod square of q is going to be k dash square minus, this is, since k dash equal to k, right, so k square mod of k square minus 2 mod square of k, because k dash equal to k. Okay, mod of k equal to mod of k dash cos theta. Right, now from here the mod square of q is going to be, this will get added, guys, this is plus. Okay, so 2 mod square of k minus 2 mod 2 k square cos theta. Okay, so from here we'll take 2 mod square of k, will take common, so this is going to be 1 minus cos theta. Okay, so from here q mod square of q is going to be, this is 2 mod square of k into 1 minus 2 sine square theta by 2. 1 will get cancelled, and this value is going to be 4 mod square of k sine square theta by 2. Okay, so from here the value of q is going to be, this is 2k sine theta by 2. Very important. Okay, the value of q is 2k sine, you need to note down, guys, this. Okay, and memorize it. And the k value of q is 2k sine theta by 2, 2k sine theta by 2, and this implies q is proportional to sine theta by 2, right? Q is proportional to sine theta by 2. Okay, so next, from here now the value of this is going to be value of scattering amplitude, f, which is function of theta phi, this is going to be, so now value of q is this. Okay, so value of this is going to be this value, we'll put it, and this value is going to be now minus 2m upon h cut square q integration 0 to infinity r and then vr is this one, v, which is function of r, potential, which is function of r, sine qr dr. This is also very important formula, guys. Many questions will be solved from this formula. Okay, and many questions are asked. Okay, and we have to use this formula to solve those questions in NET exam, GATE exam, and other exams. Okay, very important, you need to note down. So scattering amplitude f, which is function of theta phi, is minus 2m upon h cut square q integration 0 to infinity r v, which is function of r sine qr dr. Okay, and q value is value of q is 2k sine theta by 2, 2k sine theta by 2, and q is proportional to theta by 2. Okay, well, and now the differential cross section is going to be in one approximation d sigma upon d omega. This value is going to be, we know, that is mod square of f, which is function of theta and phi. Okay, so these are very important formulas you need to note down. So you will be asked in question to find scattering differential cross section. Okay, so first you will find scattering amplitude, and then you will do mod square of scattering amplitude, and you will get required answer, that is d omega, d sigma upon d omega, that is differential cross section. Okay, well, now Yukawa potential, guys. Okay, what is Yukawa potential? Yukawa potential. Yukawa potential. Okay, so that is, we know, that is V, which is function of R equal to V naught upon R e to the power minus mu R. Okay, so this is V and mu are constant here. Okay, so mu equal to constant. Okay, so this is the Yukawa potential, guys, in this form. VR, which is V is function of R. Okay, VR is equal to V naught upon R e to the power minus mu R. VR equal to V naught upon R e to the power minus mu R, where mu is the constant. Okay, well, so this is the Yukawa potential, guys. Okay, now we'll find scattering amplitude. Okay, guys, just give me some time, just 1 second. Okay, guys, so so now we'll find scattering amplitude, that is f, which is function of theta and phi. Okay, that we know. We have given VR, so what we have given Yukawa potential, right? We'll first find out this one, scattering amplitude, then we'll find differential cross section. Okay, so we know the formula of scattering amplitude, right? So that is this one, guys. F theta phi equal to minus 2m upon h cut square q integration 0 to infinity r vr sine qr dr. Okay, so this is going to be minus 2m upon h cut square q integration 0 to infinity r vr e to the vr sine qr dr. Okay, now we'll put this value, so this is going to be minus 2m v naught upon h cut square q. Okay, integration 0 to infinity, this is going to be this one, r vr value is this one, right? This one, yeah, r vr value is v naught is here, right, into 1 upon r e to the power minus mu r dr. My apologies, it's sine qr, guys. Sine qr. Okay, so this is good. R will get cancelled. Going to be minus 2m upon h cut square q v naught. Okay, integration 0 to infinity sine qr. Okay, sine qr e to the power minus mu r dr. Here it's also e to the power minus mu r dr, because this is the potential. Okay, in place of Vr we have put this value. Okay, so this is one. So this is the one, right? And so this this value is going to be now f theta and phi, this integration. So this is going to be minus 2m upon v naught upon h cut square q, and this value, this integration we know by using Laplace transform, right? I have already explained this in my mathematical physics lectures one day ago, I believe. Okay, so this is going to be q upon, this is going to be q upon mu square plus mu square plus q square. Okay, this is the value. Now how we got by Laplace transform, which I have already explained in my mathematical lectures one day ago. Also I'm going to explain here also. Okay, so this is the one. So this is the value of f theta. This is very important value, guys. So you need to note down and memorize. Many questions you can solve it directly if you know this value. Okay, so d theta f theta, d theta and phi function is 2m v naught upon h cut square q upon mu square plus q square. Okay, this is the one. Now I'll tell you how I have used Laplace transform. Okay, so we know the Laplace transform of sin r, right? How we have got this, that I'm going to explain. Laplace transform of sin qr. What is this? We know that is integration 0 to infinity fx sin qr e to the power minus sx, right? E to the power minus this is sr dr, right? This one. So now this is the one. So now and Laplace transform of sin qr we know that is q upon s square plus q square, right? And here this value is simple. This is 0 to infinity sin qr e to the power minus sr dr. Right, now we will putting s equal to mu, right? So then this is going to be q upon mu square plus q square equal to integration 0 to infinity sin qr e to the power minus mu r dr, right? This formula, this sin qr e to the power sin qr e to the power minus mu r dr, this value is going to be q upon mu square q upon mu square q square, right? So this is the formula, guys. This I have explained in my Laplace transform lecture in mathematical physics. Okay, that is lecture number 29. Okay, in mathematical physics. So this is how we got this. This is very important formula you need to know. And how we have got this value, I have already now I have explained it by Laplace transform. Okay, so this is the value. That's why the value of integration 0 to infinity qr e to the power mu r dr is q upon mu square plus q square. Okay, very important formula, guys. Next so now we know that is d sigma upon d omega, that is differential cross section. We know that is mod square of f, which is function of theta phi, right? So here we'll put the value. So d sigma upon d omega is going to be, this is going to be here, right? This is the value of f theta. This is going to be like that, right? So we'll take mod square of this, right? So this is going to be 2 to the 4 m square v naught square 4 m square v naught square upon this value is going to h cut square means h to the power, and this q square q will get cancelled, guys. Okay, q will get cancelled. This will get cancelled. Okay, so this is going to be 4 m square q square m square v naught square upon h cut to the power 4, because whole square means this mod square, right? H cut square is actually q will this one. Okay, q got cancelled, so h to the power 4, then mu square plus q square whole square, right? Mu square mu square plus q square whole square, mu square plus q square whole square. Okay, so d sigma upon d omega is this one, 4 m square v naught square, okay, upon h cut square mu square plus q square whole square. Very important formula, you need to note down it and memorize, guys, because many questions you can directly solve if you know this formula, so you don't have to go through this procedure. Okay, this procedure directly you can write this value, and you can directly get this differential cross section. Okay, if it is a Yukawa potential, 4 m square v naught square upon h cut to the power 4 mu square plus q square whole square. Okay, okay, right. Now and from here you can see d sigma upon d omega is proportional to, you can see 1 upon q to the power 4, right? 1 upon q to the power 4. Okay, and also d sigma upon d omega is proportional to 1 upon sine to the power sine theta to the power sine to the power 4 theta by 2, 4 theta by 2. Okay, sine to the power 4 theta by 2, because I have already told q is proportional to sine square sine theta by 2, right? Here I have told you, I'll show you this one. Q is proportional to sine theta by 2, so this is d sigma upon d omega is proportional to sine to the power 4 theta by 2, and d sigma upon d omega proportional to the q to the power 4. Directly we can find out from. Okay, well, now I'm going to solve a question which is asked in CSIR net. Okay, question asked in CSIR net June 2018. Okay, June 2018. Okay, guys, this is important formula, guys, you need to note down. Okay, so now we have been given VR is given beta upon r e to the power minus mu r, right? And we have to find d sigma upon d omega, that is scattering differential cross section. Okay, this is proportional to, we have to find differential cross section is proportional to what? Okay, this is the Yukawa potential, guys, right? This is in the form of VR equal to beta upon r e to the power minus mu r, right? Where beta and mu are constant. This form. Here v naught here beta equal to v naught given. V r equal to v naught upon r e to the power minus mu r, right? V naught and mu are constant. So this is the Yukawa potential, guys. Okay. Well, and options are given, guys. So very good question. Or options are given: a square plus sine square theta by 2. Okay. Option B is a square plus sine square theta by 2 to the power minus 1, and option C is a square plus sine square theta by 2 to the power minus 2, and option B is k square plus sine square theta by 2 whole square. Okay. Okay, so this is the question, and I'm going to solve it now. So we have to find this is proportional to what. Okay. Okay, so here we'll directly use the formula. We know d sigma upon d omega. This formula I have told you to note down. Okay, 4m p naught square h cut to the power 4 mu square plus q square whole square. Okay, this is going to be equal to 4 m square v naught square. So here in place of v naught is b, right? So v square, that is beta square upon h cut to the power 4 mu square plus q square whole square. Okay, v naught equal to beta here. So from here d sigma upon d omega is going to be, this is 5 marks question, guys. Okay, so you can easily solve it. So this is going to be 4 m square beta square upon h cut square mu square plus this q, will change it, right? Because answer is in sign, right? So we'll change it, and we know this is q, since we know, I have already explained, q equal to 2 sine theta by 2, right? So 2 sine theta by 2 whole square, that is 2k sine, guys, 2k sine theta by 2 whole square, and then 2k by sine theta 2 whole square, then whole square. Okay, right? So from here this is going to be d sigma upon d omega is going to be 4 m square beta square upon h cut square. Here we can take 4k square common. Okay, so 4 means it is 4 to the 4, right? 4 and then 16. Okay, so 16k square we have taken common, 16k square, because this is 2 to the 4, right? So I'll write one more step first. Okay, this is going to be h cut square mu square plus 4k squared theta by 2 whole square. Okay, so from here d sigma upon d omega is going to be, I'll take 16k square common, so this is 4 m square beta square upon 16k square h cut to the power 4, this is h cut to the power 4, h cut to the power 4 I have taken common. Okay, so this is going to be mu square upon 4k square, mu square upon 4k square, 4k square plus, this is going to be 4k square sine square theta by 2 whole square, right? So this is common, so this is sine square theta by 2 whole square. Okay, sine square theta by 2 whole square. So d sigma upon d omega is going to be, we can write this like 4 m square b square upon 16 k square h cut to the power 4, 16 k square h cut to the power 4, and this is going to be a plus sine square theta by 2 whole square. Okay, so from here you can see where a is this value, mu square upon 4a square. This is a constant, so we have taken another constant. Okay, so d sigma upon d omega from here is proportional to a plus sine square theta by 2 to the power minus 2, right? This is proportional to this, right, from here. So which option is matching, guys? Option C. Okay, so this is the answer. Very simple question, right? If you know this formula, how quickly you have solved it, right? You don't have to go through that long procedure. So I would suggest you note down this and remember it. So three formulas are very important in bond approximation. So this is number one, okay, and number two is this this one, okay, this one, and this also you should know it, right? This formula, this one, and this one, guys. This is very important. We'll solve question. Okay, so these are there are two formula for this f theta. This is the first one in terms of e to the power iota this. Okay, okay, and then this is the one. Okay, these two, and the third is the value of this one, d omega, d sigma upon d omega. This one. These formula are very, at least these three formulas are very important. You need to note down. Okay, next question is, Coulombic potential. If it's a Coulombic potential instead of Yukawa potential, then how to solve it? Okay, Coulombic potential. Coulombic potential. Coulombic potential. Okay. Coulombic potential, right? And Coulombic potential we know, right? VR, which is VR equal to minus V naught upon R, right? V naught is constant, minus V naught upon R. This is the Coulombic potential we know, right? And we know that d sigma for Yukawa potential, d sigma upon d omega we know, right? That is 4 m square beta square, or v naught square we can say. V naught square is constant, right? V naught square upon h cut to the power 4 mu square upon q square whole square. Okay, so this is the one, right? And this is mod square of f theta phi, right? This we know. This is also in the form of Yukawa potential. How I'll show you. So V R equal to, we can write like this, V naught upon R e to the power minus mu R. We can write it right here, or we can say, since and here mu is 0. If mu is 0, so this is going to be this form, right? Mu is 0 means this value is going to be 1, and this is, we can say, this value is going to be 1, right? So then this is this value is going to be V naught upon R, right? And if you square it, that is going to be minus sign is not going to change anything, right? So this is the V naught upon R. So this, if in this Yukawa potential, if you put mu equal to 0, we are going to get Coulombic potential. Okay. Well, so now if we get the Coulombic potential means, so differential cross section of for this Coulombic potential is going to be the same, and in which we'll put mu equal to 0. That's all, right? Because d sigma upon d omega is mod square of f theta phi. So sign is not going to make any difference. So it's okay, right? So this this potential is in the form of Yukawa potential. Okay, if mu equal to 0. right? Because this value is this, right? So sign is not going to change. Sign is not going to affect it. Okay. Okay. So now value of d sigma, that differential cross section is going to be d sigma upon d omega. Okay, so this is going to be 4 m square v naught square, because v naught is given, right? This one, v naught upon v naught square m square v naught square 4 m square v naught square upon h cut to the power 4 h cut to the power 4. Here, right, this is the value, guys. Here I will put mu equal to 0. So mu equal to 0, this means 0 plus q square whole square, right? So this value is going to be 4 m square v naught square upon h cut to the power 4 q to the power 4. Okay, so from here d sigma upon d omega is proportional to 1 upon q to the power 4. Okay, or d sigma upon d omega is proportional to 1 upon sine to the power 4 theta by 2, right? Because we know q is proportional to sine theta by 2, right? Or we can write proportional to cosec 4 theta by 2, cosec 4 theta by 2, cosec 4 theta by 2. Okay, cosec 4 theta by 2, right? For Coulombic potential, these are the answer, guys. Okay, the value of d sigma upon d omega, right? So Coulombic potential is also in the form of Yukawa potential. Okay, and where we'll put mu equal to 0. Okay, and mu, that is constant, which is equal to 0. Then if mu equal to 0, in that case Yukawa potential becomes Coulomb potential, right? We can say. Okay, guys, so this is done. Next question. Next question is, this is question VR VR equal to beta upon r square. Okay, VR equal to beta upon r square, right? This is the potential given, guys. Okay, now we have to find out differential cross section. Okay, so first we have to find out d sigma upon d omega is proportional to. Okay, so first we will find scattering amplitude, that is f, which is function of theta phi, that we know minus 2m upon h cut square q, 2m upon h cut square q, 0 to infinity r vr e to the power minus r vr sin qr dr, right? Sin qr dr. This is also very good question. So this is going to be minus 2m upon h cut square q. Okay, and this is going to be r, vr value is beta upon r square sin qr dr, right? F theta phi. So f theta comma phi is going to be minus 2m upon h cut square, r will get cancelled, 0 to infinity, this is going to be beta will take outside, so this is sin qr upon r dr. This integration I in my 2 days ago I taught Laplace transform, right? and I have told you this integration is very important, and I have solved it by Laplace transform as well, and also I have told you to note down its result, right? The value of, I have told, I have solved that as well. The value of 0 to infinity sine t upon t dt, right? That value is pi by 2. So this value is pi by 2, guys. You need to note down and memorize it, because I have already explained it in my mathematical class. Okay, and right. So this one, right? So we can easily solve it by Laplace transform. Okay. So now I'll directly write this value. So this is going to be f theta comma phi, f theta comma phi, that is scattering amplitude, is going to be minus 2m upon 2m beta upon h cut square, and this value is pi by 2. Okay, pi by 2. So now pi by 2. Okay, since I can write it, this value is 0 to infinity sine qr upon r. This value is pi by 2. Okay, so this is going to be, this value is this, right? So now what we are going to do, now we'll find a differential cross section, right? D sigma upon d omega. So that is f theta phi mod square, right? So this is going to be 4 m square beta square upon 4 h cut square. 2 will get cancelled here. Okay, 4 h cut square, 4 h, I'll cancel here, 4 h cut square. Okay, 4 h cut square phi square. My apologies. So this is phi square. 4 will get cancelled. Okay, 4 will get cancelled, and this is q, guys, right? H cut q, guys. Okay, so h cut q. So this is going to be h cut q is q square, right? So d sigma upon d omega is, from here, is, you can see, proportional to 1 upon q square. That's what we need to find out. This is proportional to 1 upon q square. 1 upon q square. This is the answer, guys. So you need to note down this. Okay, I have already explained this using Laplace transform, guys. Okay, and also Fourier transform, I have also explained this. So very simple. Next question is, so please check my mathematical physics class of Laplace transform and Fourier transform. I have explained this there. Okay, next question is, this is also very good question. We have been given VR, that is potential is given, guys, that is equal to sigma L V naught A cube del cube R minus Ri. Okay, at low energy level, low energy level. Okay, so we have been given potential VR, this at low which is at low energy level. Okay, and here Ri is position vector, position vector of vertices of a cube, vertices of a cube of length A, centered at origin. Okay, Okay, so Ri is position vector of vertices of cube of length A centered at origin. Okay, so simple. So we have been given this and we need to find out d sigma upon d omega. Okay, so I'll solve it. This is also question asked in NET, guys. Okay, so now I'm going to solve it. So we know that scattering amplitude f comma phi equal to, here I'm going to use this formula, guys. I'll show you this one, the first formula which I have written. Okay, this one, minus m upon 2 pi h cut integration Vr e to the power minus q minus iota q dot r d tau. Okay, this I'm going to use it. Okay, so I'll solve it. So this is minus 2m minus minus m upon 2 pi h cut square minus m upon 2 pi h cut square integration, that is volume integration e to the power iota q dot r, and this is minus, guys. Okay, e to the power iota q dot r, this is minus 1. I'll show you. This is minus. Okay, so this is going to be, yeah, minus m upon 2 pi h cut square volume integration e to the power iota q dot r. Okay, iota q dot r, and that volume, this is given, this is like, because this is Vr, right? This one, I'll show you. Vr and then e to the power this, and Vr values, where Vr value is given to us, and that is this one, q dot r. Vr value is this v naught a to the power 3 del cube r minus ri. Okay, this one, and d r or d tau, this is d tau, guys, d tau. Okay, this is volume integration, so that is d tau. The same thing is given here. Okay, so this is d tau. I will show you here. This is d tau, guys. Okay, d tau. Okay, so now we'll solve it. So this is going to be, we'll take at low energy level, right? at low energy level. Okay, at very important condition. Okay, at low energy level, q is going to be very small. Okay, small, q is going to be small. It means q tends to 0. Q tends to 0 means we'll put q equal to 0, so f theta phi is going to be minus m upon 2 pi h cut square volume integration e to the power 0. Q is tends to q equal to 0. Q is very small. Okay, tends to 0. That is v naught a cube del cube r minus ri factor d tau. Okay, and this value, and then value of this is going to be f comma, f is function of theta phi, so this is going to be minus m v naught a cube, will take common this constant. Okay, and e to the power 0 equal to 1, e to the power 0 equal to 1. Okay, this we know. So from here this value is going to be v naught a cube upon 2 pi h cut square, and this is going to be volume integration del r minus ri beta, right? So this value is going to here the value of integration, we know, right, in Dirac delta function, integration del d r minus ri beta equal to 1, right? But there this value is 1, right? But there are 8 vertices, right? In cube there are 8 vertices. So this is going to be m v naught a cube upon 2 pi h cut square. And this, because we know the volume integration of Dirac delta r minus ri beta is 1, but here there are 8 vertices, so this value is going to be 1. 8 times 1, 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1, 3, 4, 5, 6, 7, 1. These are 8, 1, right? So this is going to be, this value is going to be minus 8 m v naught a cube upon 2 pi h cut square. Okay, so 2 will get cancelled. This is going to be minus 4 m v naught a cube upon pi h cut square. Okay, now it from here d sigma upon d omega, this value is going to be d sigma upon d omega. This is f theta, mod of f theta whole square, right? So this is going to be, we'll square it. So this is 16 m square v naught square a to the power 6 upon pi square h cut to the power 4. Pi square h cut to the power 4, and this is the answer, guys. Okay. Well, the Born approximation is completed here, right? In next lecture, I'm going to explain relativistic quantum mechanics, and then the quantum mechanics is going to be completed. Okay. Okay, guys, so I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. Okay, guys, thank you. Bye now.